So in this video, we are going to use the double angle identities. So if you can find the double angle identities, again, on that sheet that I have in Canvas. And so, for example, find the sine of 2x, the cosine of 2x, and the tangent of 2x if the cosine of x is equal to minus 4/5 and it's in quadrant 2. So before I even do the problem, I'm going to take care of drawing my angle and figuring some stuff out about that. So I know I have an angle x and that it's sitting in quadrant 2. So this is my angle x. So if I were to make that reference triangle, I know the cosine is negative 4/5. So we're going to have a 4 and a 5. This would be a negative 4 because it's on that negative side of the x-axis. And I can use Pythagorean Theorem to find the other side. So we're going to have a squared plus negative 4 squared equals 5 squared. So a squared plus 16 equals 25. Subtract 16 from both sides. A squared is going to be equal to 9. A is equal to plus or minus the square root of 9, which is plus or minus 3. And then to see whether it's a positive 3 or negative 3, I have to look at my triangle. So the y value here, it's going up, so it's going to be a positive. So that angle we found, or that side we found, is a positive 3. And now it's just a matter of pulling off the things we're looking for from the sheet. So for instance, the sine of 2 theta, and this is from our sheet, is 2 sine theta cosine theta. So we have an x instead of a theta. So we have the sine of 2x is 2 sine x cosine x. And based on our triangle here, we have 2 sine x is 3/5, cosine x is negative 4/5. So we end up with negative 24 over 25. If we're looking for the cosine of 2x, so from our sheet, it tells us the cosine of 2 theta. It gives you 3 different ones you can use. You can use any of them, it doesn't matter. So we'll just take the first one, cosine squared theta minus sine squared theta. So in this case, cosine we said is negative 4/5, so negative 4/5 squared minus the sine, which is 3/5 squared. So we're going to have 16 over 25 minus 9 over 25, which would bring us to 7 over 25. And then the last one it wanted us to find was the tangent of 2x. So you'll notice there's not actually a formula for the tangent of 2x, but remember, tangent of 2x is going to be the sine of 2x divided by the cosine of 2x. And we already just found the sine and the cosine. So the sine of 2x is negative 24 over 25. The cosine is 7 over 25. If I do keep, change, flip, so keep negative 24 over 25, change the multiplication, flip that last fraction to 25 over 7. The 25s would cancel, and I would get negative 24 over 7. I should say you could also have used the tangent formula that is on the sheet. So there's tangent of 2 theta is 2 tangent theta divided by 1 minus tangent squared theta. And I'm just going to kind of move this way. So if I did that here, we're going to have 2. The tangent is negative 3 over 4 divided by 1 minus negative 3 over 4 squared. So this would end up being negative 6 over 4 divided by 1 minus 9 over 16. So negative, we could reduce this to 3 over 2. Right, 2 goes into 6 3 times, 2 goes into 4 2 times. So this is going to be negative 3 halves divided by 16 over 16 minus 9 over 16. And so 16 minus 9 is 7 over 16. So this is going to be negative 3 over 2 divided by 7 over 16, which, again, if you did keep, change, flip, you'd have minus 3 over 2 times 16 over 7. The 2's would cancel, and you would get that exact same answer of negative 24 over 7. So if you've already happened to find the cosine of 2 theta and the sine of 2 theta, it's probably a little easier to do it that first way I did it. Otherwise, you can plug into that same identity.